Yeah, in the previous session, we discussed about, I explained you guys completely about the shift instructions. There are various shift instructions. There are various shift instructions: shift right, shift left, arithmetic shift right, arithmetic shift left, circular shift right, circular shift left, rotate right through carry, rotate left through carry. What is this carry? I mean, this shift will happen via carry. What is a carry? Carry is the next digit, right? Next to the MSB, that is extended accumulator. All will get rotated through the carry. Okay, all these shifts we discussed and explained you guys in the previous slide. So these are the shift instructions, various shift instructions. Let us go to program control instructions. As I already told you that the program will get altered. A sequence of the program will get altered from one sequence to another sequence. Rather, the control of the program will get altered from one sequence to another sequence. For an example, I am executing 20-second instruction, let us say. After executing, what you will execute normally? Normally, after executing 20-second, I need to go to 23, except if the current instruction is a branch instruction. When a branch instruction gets executed, I don't take the regular path of the program, that is 23, 24, 25. Rather, I will branch to another sequence of the instruction. So generally, one inline sequencing, that is program counter is equal to program counter plus 1. I will go ahead. But when the current instruction is a branch instruction, the sequence will get altered. What is the next instruction? Next instruction is fetched from the next adjacent location in the main memory, consecutive location in the main memory. Okay. But when the current instruction is a branch instruction, what I'll do? I will go to an address to which branch is pointing. That is, we are going to say, we may take address from a different source. Rather, in the current instruction, we go to the address part. You know that, right? Let me show you once again. Let me draw this. Insert. Now, let us say branch BSA 450. Where I will branch, I don't take the next instruction. Let us say BSA instructions address is 21. Okay. Will I go to 22? No, we are going to 450. Okay. So we are going to take the address from the current instruction itself. Generally, we need to take the address from the program counter. But during branch instructions, we may take the addresses from the different things. If we collect the address from the program counter, then we are sticking to the same sequence of instructions, no alterations. But during the branch instructions, what we do is we will collect the address from the different sources. Okay. So in this case, we are going to address part of the instruction. We are taking it as the next address and we are going to 450. But before that, I know you people know that how to save this program counter value. Program counter value will be pushed into the stack. I told you guys while I was explaining a session, I was taking a session, that is the provisions to store the program counter value. Okay. So the address can be taken from the current instruction, maybe a stack. Of course, when you push the program counter value into a stack, in order to return back, we are going to pop the value of the stack out. So thereby we will go back to the previous routine, which was suspended. All right. So the branch instructions, these branch instructions are going to alter the sequence of the current instructions in a program. Generally, the program is going to get executed. The instructions of the program are going to get executed one after another. Normally, we're going to take the next instruction's address from the program counter. But during branch instructions, program counter value will not be taken. Program counter value will be rather saved somewhere. And we go to another sequence, and the address of that subroutine may be collected from the current instructions address part. Okay. So let us see what are those instructions. Branch. branch instruction is going to take you to the some address which is provided in the address part of the instruction. Example is BSA, that is branch and save the return address. Jump, what is jump? We are directly jumping. What is jump instruction? BUN is a jump instruction, right? Yeah. Skip, we are going to skip the next instruction. Call is BSA. Call is exactly BSA. We are calling a subroutine. Return, we are returning from the subroutine. Okay. There is something called compare and there is something called test. What are these? Just let us have a look at. Okay. Let us see the different conditional branch instructions. In CPUs, different CPUs will employ different conditional branch instructions. Some examples for the conditional branch instructions in different CPUs such as Celeron 8086, Pentium, i3, i5, i7, i9 are as follows. This is the conditional branch instructions. This will be the comparison. Okay. We're going to make a comparison. And this comparison is successful, then we are going to take a branch. If the comparison is not successful, then we are not going to take a branch. Okay. These are conditional branch instruction. Conditional branch instructions meaning we need to evaluate a condition. Okay. This evaluation will be done by some comparison. What is this? Try to understand. BZ, branch if 0. Okay. If some value of a variable is 0, then we are going to branch. Value of that variable is not 0, then we are not going to branch. Okay. Here, what is going to be checked here when we execute BZ instruction? Let us say an instruction that is BZ 450. We are going to branch to 450. I'll take the next previous one. Okay. One instruction at 21 is, let us say, it is BZ 450. Okay. What is BZ 450? Branch if 0 to 450. We will go to 450 location only in case if this condition is evaluated. Okay. If this condition is evaluated, what need to be checked here? Try to understand. You people knew that there is a flag register. Okay. What is the flag register? Flag register held a few flags. You remember? Let me show you the flag register again. Okay. There are several flags here. That is, there are several flags in the flag register. Some common flags, sir. Some common flags, sir. Some common flags, sir. 0 flag, sign flag, carry flag, overflow flag. Okay. So now we will check the flag register for evaluating a condition. Okay. Let us go to that. Now, branch if 0. We are going to branch to 450th location if 0 flag is set. Otherwise, we don't branch. Simply, we go to take the next instruction. Next instruction will get executed. If the condition is satisfied, I will branch to 450. If the condition is not satisfied, I will take the next instruction, that is 22nd instruction. Branch if not 0. There is something called branch if not 0. So for that, we need to go to the 0 flag. We will see if the flag 0 is equal to 0. Okay. If 0 flag is set to 1, that means that the output of the ALU is 0. If the 0 flag is 0, that means that the output of the ALU is not 0. So we go to branch, we go to 450. That meaning we are going to take a branch if branch is not 0. Okay, if branch if not 0. If 0 flag is not set, then we are going to take a branch. Next thing is branch if carry. We go to carry. If the carry flag is set, we are going to branch. If the carry flag is not set, we are going to branch for these 2 instructions. Okay. And branch if plus, meaning the branch if positive, we go to sign of the result of the ALU. If the sign is positive, we're going to take a branch. If the sign is positive, we go to 450. Otherwise, we go to the next instruction, that is 22. Okay. Branch if minus. If sign is 1, we go to 450. Otherwise, we go to 22. Okay. Then branch if overflow. We'll check overflow flag. If overflow is equal to 1, we're going to branch. Otherwise, we don't branch. Branch if no overflow. If overflow is 0, we're going to make a branch. We're going to take a branch. Otherwise, we don't take a branch. That is it. Okay. There is an unsigned comparison also. Okay. Branch if higher. Now here, in order to make this unsigned comparisons, what we do is we need to take two variables. Okay. If these two variables will be compared, based on this comparison, if it is successful, we're going to take a branch. Okay. Branch if higher. If A greater than B, we're going to branch to 450. Branch if higher or equal. If A is greater than or equal to B, we're going to take a branch. Otherwise, we're going to take the next instruction. Branch if lower. If A less than B, then we are going to take a branch to 450. Otherwise, we'll just execute the 22nd instruction. Branch if lower or equal, we take a branch to 450 if A is less than or equal to B. And similarly, if A is equal to B, we are going to take a branch. If A is not equal to B, we are going to take a branch. Every time any of this instruction gets executed, if the condition is successful, then we are going to take a branch to 450. If any of these conditions are not successful, then we will go to the next instruction. Branch will not be taken, rather we'll go to the next instruction. Similarly, the signed comparison, branch if greater than or equal to, less than or equal to, equal, and branch is not equal. Okay, these are signed comparisons. An unsigned comparison will be performed in between two numbers that are unsigned. A and B, regardless of their signs, will be compared. But the signed comparison will be in between two numbers which are signed. Okay, so try to understand. A branch instruction is going to take a branch. Where we are branching, look at the address part of the instruction. We will go to this address part of the instruction in which a subroutine is available, provided this condition is successfully evaluated. If this condition is not evaluated, if the condition is false, then we are not going to take a branch. Rather, the next instruction will be fetched and executed. This is nothing but program control instructions and the purpose of program control instructions.